when you create the tree, uh, there are some ways how to create the best tree. Maybe I will just show you the simple example how the classification works. So when you do the classification, let me just give you the overview how usually we start from the scratch. When we know that the decision is by computer, so let's say if I just use only one color, which is the edge, what is the tree? So the tree is like this one. It means the most possible attribute for splitting is only one, which is the edge. Okay, and if you see this one, the branches now it's split into three. It means I will not do the binary tree. Okay, so this is not induce the binary tree. And if you check this one, the color is red. So it means this is the perfect. We have 100%. All the data is in the decision yes. But if the color is white, so it is still less than the expectation. You can see it's about 60%, and this is also 60%. Okay. Of course, if it is more dominant to yes, the color is above red, but it's not red. If it is more dominant or no, maybe the color is a little bit blue. So you can see from the color, okay? We can see the tendency, whether it is more yes or more to no. Now, if I have the additional attribute, then it will increase the tree complexity. Okay. So the additional attribute, we have the edge, and then we have the attribute whether the person is student or not. So the additional attribute increase the tree complexity. I have the edge attribute to split the first, and then I use the student information to split the node that still can be split. So this information can split to no and yes, and this also can be split to no and yes. If you look at this, it seems that the leaf is the node that has no other branches. It's good because it shows the color blue and red. But this one, we still need to have like 50-50. So we can say that, yeah, in this case, we need to have more attributes. What kind of attribute that can help to split this one? Or what kind of attribute that you can verify that the result is getting better? So you can have another attribute. If you have another attribute, then let's say this is income. Okay. So I use income. But if you see this one, the most important attribute is age, and then we split again with the attribute student in this case, and we split again with the attribute student. So where is the income? There is no income. in this case. Why? Based on the calculation, if you still remember the Gini index, the gain, the information gain, the gain ratio, it means the attribute student is still higher than the income. So the additional column does not affect the model. So the income does not affect the model. If you check this one, let's say I have a new column, credit rating. So if I put the credit rating, and now based on the calculation, the credit rating gives more confidence to select the decision, either yes or no. So if the credit rating is excellent, the decision is toward no. If the credit rating is fair, the decision is more to yes. Then you can see this one. Now it is perfectly distinguished. So if you can get this kind of tree, it means this is the best tree. Now let's see with the real world data. Let me use the data set. Okay. So we have the widget data set here. So last time we already used the widget data set. And then let's use another data set. We call it the MPG. There is the auto MPG data set. And then you can look at this one. This is the data concern the city cycle fuel consumption in miles per gallon. So you know car, okay? The car will have the fuel, and they want to predict the fuel consumption. So you can double click here, and then you can open the data table. So if you look at the information here, we have 398 instances. We have 7 features, and we have some missing data. We have 0.2% missing data. And if you look at this one, the gray color, like this gray, it means this is the target. This is the target. MPG. MPG means the miles per gallon. I don't know in Korean, but usually it is a measure to check whether your car is efficient or not in the fuel consumption. So, for example, we have 18 miles per gallon. When you fill your car with the fuel, so for every 1 gallon, your car can run for 18 miles. And we can check what is the car name. Okay, the car name is Chevrolet. Chevrolet. Okay. And then the cylinder of the car is 8. Displacement, this is one characteristic. I'm not sure how to explain this one, but they have number. 307. Horsepower, it is the energy of the car, 130. weight of the car, the acceleration, and then the model year. And they have also the data about origin. Maybe they have the description. One means from USA, maybe 2 or 3 from another country. But let's just use this number. So we have this data. Then how we can do the prediction or the classification? So first, of course, you need to define what are the values of the data, or what is the data type. So the MPG, we know that it is continuous. The cylinder, yeah, is multi-value discrete. What does it mean? Cylinder, multi-value discrete. We have 8, sometimes we have 4, 6 cylinders, but yeah, there will be no 5 cylinders. There will be no 7 cylinders, because in car they have a fixed number of cylinders. Maybe we can have 3, we can have 4, we can have 6, we can have 8, but no 7, no 5. So it's a multi-value discrete. And displacement, continuous, continuous, continuous. Yeah, it is discrete with multi-value. Origin, it is a multi-value discrete. Hardening. Do we need to use hardening? In this case, yeah, it is not useful because it is unique. Then there will be question like this one. Construct the regression tree, and then construct the classification tree, and compare several classification algorithms. And then create a categorical data from the numerical data. For example, a value is high if it is higher than the average, else it is low. So first, let's construct the regression tree. Do you know what is regression tree? Maybe for the easy way to understand this one, let's open the orange file. I give you this orange file, the classification with MPG dataset. So the dataset that we are going to use is the Alto MPG. And then let's check the feature statistics. Okay, there are some missing value here. The attribute horsepower, we have the missing values. And then, okay, only this horsepower that's missing values. We can make the tree, we can create the regression tree directly here. What is this regression tree? Actually, this regression tree is the common tree. Okay? You can just use the tree, and then let's see this one. What does it mean by distributor? If you still remember, when you do the classification, especially if our data is numerical, then we will make only 2 branches, and we will select the splitting point. So let me get back to the previous one. In the select column, let me include the balance. So I will include numerical attribute. And let me check the tree viewer. No, it does not event. Let me just include the spending as well. Okay, now you can see that the tree include the spending. So the spending is the most important attribute. But let's see, what is spending? So the column spending, it means, yeah, it is a number. I guess this is the spending that the person did, maybe in the spending in 1 month, $5,100 maybe. So this is numbers, and we want to use these numbers. We want to use this information to check whether the person will buy a computer or not. So based on the tree viewer, the most important attribute is spending, and the splitting point is 6,200. 6,200. If the spending is less than 6,200, then we go to this section. If the spending is higher than 6,200, we go this way. Okay. This is based on the spending. So let me get back to this one. If we use the buy computer data, the decision is yes or no. Okay. But what about if the decision is MPG? What is MPG? Miles per gallon. So the decision here, it is 23.5. What does it mean? Can you guess? This is the average. This is the average of MPG among all the data. So among 398 instances, yeah, the average is 23.5 miles per gallon. You can check this one. Let's see. This one. 23.5. This is the mean. Okay, this is the average. So if I know that this is the average from 398 instances, and then I will check based on the Gini index, based on the gain information gain and gain ratio that you learn. So in the orange, basically they use the information gain, and they know that the cylinder is the most important attribute. Okay. So the cylinder, if it is 3 or 6 or 8, it will go to the left. If the cylinder is 4 or 5, it goes to the right. Okay. Oh, we have 5. Oh, okay. So if the cylinder is 3, 6, and 8, okay, the miles per gallon is 17.3. So it means it is low. But if the cylinder is 4 or 5, the MPG is 29.3. Okay, so the car is better with the cylinder 4 or 5. And then again, you will split with the attribute. Now you can see the displacement. The displacement, if it is lower than 267, the MPG is 20. This is the average. This is the average. If the displacement is higher than 267. What about here? The next attribute is weight. So if the weight is less than 2215, the MPG is, it's very high. So maybe if the car weight is very light, then the MPG is high. If the car is the weight is very high, then the MPG is low. Okay? So we can make the analysis based on this one. So for your team project, you need to mention this kind of analysis. So you need to understand each of the value and what is the condition that they use to split the decision tree. For the regression, okay, you already know in the exam, there are some measures. If we are using the regression, then the measures will be mean square error, RMSE, MAE. You know what is it? MSE, mean square error. RMSE, it is the root mean square error. So we learn in our PowerPoint. MAE is the mean absolute error. We have the R square. I did not discuss in our case, but the R square is the correlation value. If it is closer to 1, then it is good. So the error should be low or closer to 0. Okay. So it should be closer to 0. The error should be closer to 0. Closer to 0 is good. But for the R square, closer to 1 is good. Okay. So if you check this one, the RMSE is 3. Okay, that's good. The MAE is 2. Okay, this is quite good. And the R square is 0.7. Okay, this model is quite representable. Okay. Now, if I want to make the classification, what is classification? We know that the classification is a way to do the prediction using categorical data. What is the MPG? MPG is continuous data. So if we want to make the classification, we need to make the categorical data. How? We can convert the continuous data into categorical data. There are some ways. So you already learned. For example, you can use binning. Okay. You can use the equal width, you can use equal frequency. You can use clustering. So we will learn clustering in the next in the next week. Okay, I guess we will learn clustering. And or you can use some other ways that Orange prepare for you. So for now, I will just give you example with very simple way. Let's say this one, if the MPG is higher than 23.515. So this is the average. So if the MPG, miles per gallon, is higher than the average, I can say it is high. If the MPG is lower than this value, then it is low. So you can make this new variable. Okay, it is low. Why it is low? Because it is lower than 23.5. Let's say this is high. This is high because the MPG is higher than 23.5. So I make the two categories, low and high, based on the average. So if I already have this category, then I will use that category. I will use this category to be the target. So I want to know which car, or I want to check all the features of the car that can represent the MPG, whether the MPG is low or high. But there is one thing that you need to know. The MPG category is created from the MPG. It means if you use the MPG value as in the features, is it okay or not okay? If I use this one, okay or not okay? Not okay. Why? Okay. Why? We can check this one if we already have the feature constructor. Let's check the correlation. Sorry, you cannot see the correlation. We can check the rank. It will be very good. We need to check the rank after the select column. So if I include the MPG, you can see the chi-square. Okay. Do you still remember the chi-square? What is chi-square? It is to check the correlation for the categorical data. Okay, so please check again the column. What is the category here? The category here is the target that you already select. So it means we have two categories, which is high and low. Okay. And based on this one, chi-square value is the MPG. Of course, it is high correlation because the category is from the variable MPG. So that's the reason that we cannot use MPG, because we derive the category from this MPG. Okay. So later on, if you create your label or if you create your target from every attribute, you need to check this one. And for the highest correlation, you need to figure out whether it is available for your analysis or not. So like this one, the MPG, of course, it is not reliable because it is the derivation of the category. That's why we need to exclude this one. And if you exclude the one, then this will be the most representative attributes. And based on this, I will just select all the columns. Or yeah, you can see this one. What is the highest chi-square? If you want to choose manually, yeah, you can choose. Okay, I will choose this attribute, this attribute. I will choose this attribute for doing the classification because this acceleration is very low. Or you want to select the best 5. The best 5 is this one. Okay, you can select it. Or okay, I just want to include every of this attribute. Then you can also do that one. And you will check this one based on the decision tree, and you can check the accuracy. Okay, the accuracy is 90%. That is good. So for this one, there will be a comparison. So here I just use the comparison with another algorithm. Okay, maybe I cannot explain all the algorithms now. At least you know one algorithm, which is the decision tree. So I will just use the tree, and then I will use the random forest. This is another algorithm in the classification. So you can check on the model. So in the model widget, yeah, you can see some of the model, the possible model that you can use. For example, this is the CN2 rule induction or calibrated learners, KNN. 3, random forest, gradient boosting, SVM. So there are some algorithms that has been dedicated in the ORINTS. You can use this one for your comparison. So let me just use 3, okay? 3 and then random forest and then SVM. And then I want to check. Based on the result, we have, okay, 90% accuracy for the 3. If we use the SVM, 89%. If we use the random forest, 91%. So which algorithm that we need to choose? Usually we will choose the highest accuracy. It means we will choose the random forest algorithm. And if we have this model, we can use the later to apply in the real problem. So it is practical to compare some other algorithms. Yeah, you can include with other algorithm if you want. If you want to include this one. So that's why it is very easy to use ORINTS, because you can just click and click, and then you can get all the result immediately. Yeah. So here the KNN give you 85%, the naive Bayes give you 89%. So the random forest still the best. And you can compare this one. Um, you can compare the models using this kind of table to check whether the model, which one is better compared to the other models. So when you do the team project, I guess you will do something like this one. At the final stage, you need to check the accuracy. What is the highest accuracy? And then what is the possible algorithm that you use and how you can interpret. If you have this tree, how you can interpret the tree. In this case, most of the data contain low MPG. Okay, because 52.5% they are low. And then the first or the most important attribute is displacement. If the displacement is less than equal to 180, then the MPG is regarded as high. If the displacement is higher than 183, the MPG is low, and so on. So you need to give your explanation on your project. Okay. So this answer all the questions. Okay. And this is also only for the classification tree and the regression tree. If you have 4 members, yeah, you need to find another task. Okay, so we will learn about the clustering, and then we will learn other things. And yeah, you can split the task for the members according to the task that I will explain. So that's about the classification and the prediction that we learn. And if you look at this rank, actually you can see this one, the scoring methods. You can use the information gain. You can use the information gain ratio. You can use the Gini decrease. Okay, so those algorithms you already learned from the PPT. So you can also put this one, and you can check what is the most important attributes based on the information gain, based on the gain ratio, based on the Gini, and based on the chi-square. And the in orange, you can see this one. Missing values will be imputed as needed. So you can see the previous one, there is some missing values. Okay, there are some missing values here, horsepower. So the horsepower, I think they use some imputation basic from the orange, and then this horsepower has been imputed. So there is no missing value for this attribute. That's why we can have the information gain, we can have the gain ratio, Gini, and the chi-square. Okay. Any questions? Then you can see also the assignment score. Yeah,